Hello everyone, my name is Neemchan Jangri and today I am excited to present our project SmartGeo. This project is developed under mentorship of Prashant Srivastava and developed by me and my teammate Vishesh Gautam. Imagine if you have to calculate an area, width, length, height or estimated score of suitability for a infrastructure in a time. What will you do? Traditionally, we will send some team of surveyor for survey that infrastructure and physical visit of that infra and fields, and it will take heavy equipment and a lot of time, a lot of resources for that. So there is an issue in that. If our engineer want that quick data, they uh, they won't get, and there will be physical human limits for it. It will take processing, it will take time for technical processing of that field, and there could be errors in area and many more things. So here is system introduction. So our system gonna analyze satellite based imaging data in real time, and we're gonna get height, length, width and area of that infrastructure. The special things about project, we're gonna get a suitability score of that field, and um, it will tell us that if that field is suitable for construction or not. So overview of how our system works. So for the user perspective, user will just select the point to point map of that infrastructure, and our system gonna run it point to point and give exact area of that infrastructure. And along with that, we system will analyze our suitability score and the project feasibility on that field, and we're gonna run our machine learning models for that, and it will give us things like how suitable is there for a building to be construct. So by this project, our goals and objectives are clear. We're gonna divide it into three parts. First, exact dimensions. We're gonna analyze the field and get you area, width and length, estimate heights. We're gonna implement our models, and the height will be calculated by shadow and the geometry of that area, integrated area. So we're gonna deploy our advanced machine learning models in that, and we will get you a suitability score, which I previously mentioned as feasibility score types. And from here, my teammate Vishesh Gautam will give you the technical background and all other things about the project. Thank you.
So, hello everyone, I'm Vishesh Gautam and I will be briefing you about the technical details of this project. And firstly, we are using major two formulas in this project. First is shoelace and second is Haversine formula. Shoelace formula actually tells the exact polygon areas to be taken during the selection of region, and the Haversine formula actually tells us about the two surface distances between the structures that we are analyzing. And we actually take the pixels and convert into meters for further analyzing and finding the right height, width, length and all. So the core part, the most special part that we are working on is height estimation. So actually we are finding out height by two ways. First is through open elevation API, and the second one is by shadow. That's the best part. We are actually seeing at how much angle the sun was at that place that we are fetching the location from, and how much, what is the distance of the shadow that it is portraying on the ground. So we are using basic trigonometric formulas to calculate the particular height of that structure and finding out the height, and then showing on the dashboard of the website. So firstly firstly, we are using AI in this, and we are using some machine learning models and some deep learning models in it. Firstly, in machine learning models, we are using models like random forest to find out the best suitability around that area to construct any infrastructure over there. And secondly, we are using CNN. Firstly, we are using YOLO model to detect buildings and roads across that area. And secondly, we are using CNN in our deep learning model, and it actually differentiates between the shapes, geometry, and particular features of that particular area. Uh, that's all it does. So there are briefly three layers in our project. First being front-end layer, which actually works on React.js, and it handles all the map interactions and all. And we have the backend API layer, which manages all the requests that are being put into it. And the third one being is the processing engine, which actually is the main backend part of our project, which uses Python and OpenCV for processing the raster images and data that we are getting from input and using API and all. Although our system is actually very robust and stable, still it has some limitations added to it, and some limitations being these all. Firstly, there is already some proven geometric data that is there and that we are fetching, and that is a big limitations to our project. And the second being the noon part. Actually, our project fetches the data through the distance the shadow is during the daytime through sunlight. So actually, when it is actually noon, then it won't be able to get the right data. And third being heavy cloud cover density, which would also affect the height estimation part, because there won't be sunlight anymore. And some even in dense forest regions, it would again be difficult to find the shadow. These are some basic limitations, but still our system is very robust and tells a very accurate metrics about those particular computations and all. And that's all. So this is a wrap of our project. We would like to tell all our contributions in it. So firstly, Nemi will tell all his contributions.
I did the front end part and the feature selection part, like how we're gonna do this shadow thing, and how we're gonna manage the area and the width, the height, and how exactly we're gonna build the suitability score, and the pipeline part, like the user will do this and our system gonna do this and all. And after that, the PPT, the PPT design is designed by Vishesh Gautam, and the material in it, the text and all, is selected by me. And the further contribution of our mentor Prashant Srivastava, that was fabulous job. And now my teammate Vishesh Gautam will tell you about his contribution and some of his help.
Okay. So my contribution mainly was for backend and database. So in backend, I use Python and OpenCV for analyzing and processing the raster images that are being fetched from the website dashboard, and analyzing them and putting computational these models and formulas for it to find the height, width, length, and all the other metrics that were in the website. And I worked on models like CNN and random forest as well. And then in the end, I would really like to thank our mentor, Mr. Prashant Srivastava sir. He really guided us so well, and that's all. Thank you.
Thank you.